Alright, so let's take a look at your guided practice for 1D. And so your first question deals with that scene from Princess Bride, and we're trying to decide if Zeeny's using inductive or deductive reasoning. So let's kind of review what inductive and deductive reasoning are. And so starting with inductive reasoning, uh, with inductive reasoning, we kind of have this situation where we're saying, okay, I've seen this happen in the past, maybe 2 or 3 times it's happened, and so I'm going to assume it's going to keep happening in that same pattern in the future. Okay, and so I got this example from Sister Chapman. She says the way she remembers, she says, okay, I have this duck and I put it in the water and it quacks when I put it in the water. And I take another duck and I put it in the water and it quacks when I put it in the water. And I take a third duck and put it in the water and it quacks when I put it in the water. And so now with my fourth duck, I am assuming that when I put it in the water, it will quack because that's what I've seen happen in the past. And so I'm using these very specific examples that I've seen. Each of these specific ducks quacked when I put them in the water to come to a general conclusion. When I put a duck in the water, it will quack. And so any duck that I put in the water will quack. And so that's an example of our inductive reasoning, where we're going from these very specific examples to a general conclusion. And so we're using these specific examples and assuming it's going to keep happening. This pattern that we've seen is going to keep happening in the future the same way. And we really can't prove anything using inductive reasoning, because just because it happened that way before doesn't mean it's going to keep happening. But we can kind of make some assumptions and say, okay, probably this is going to keep happening, or this is what I've seen in the past, and so I'm assuming it's going to keep happening. And it can lead us to some conclusions, but it can't prove anything that way. Alright, so let's talk about deductive reasoning now. Deductive reasoning works where we have some generally accepted premises that lead us to a conclusion. Now, that's more specific. And so we have, say, premise A leads us to B, and we have a premise B leads us to C. Therefore, my conclusion is A will lead us to C. Okay, and so an example of this one, we have a premise, all squares are rectangles. Then we have another premise, all rectangles have 4 sides. And so then our conclusion is that all squares have 4 sides. And so that's our deductive reasoning. We're using these generally accepted premises to come to this conclusion here. And so that's what you want to think about as you're evaluating this scene from Princess Bride. Is he using inductive reasoning, saying, okay, I've seen Wesley do this in the past, and therefore I'm assuming he's going to keep doing this in the future? Or is he using this where, okay, I have this premise here and this premise here, and I'm coming to this conclusion based on those premises? Okay, so hopefully that'll help you reason through that part. Your next question on there is the question dealing with, okay, all U.S. presidents have been men, and Ronald Reagan was a president, and then we have this conclusion that Ronald Reagan was a man was our premise, and then we have a conclusion that Ronald Reagan was a president. And the truth is, you have an example almost exactly like this in your textbook. And so if you take a look at example 4 on page 45, almost identical. Okay, and so that's my recommendation on this one. There's a really good example already there. And so take a look at that one, and then also think about that converse fallacy that we saw in our last guided practice from last week, and that can help you out with this one. All right, then our last one is our Goldbach conjecture. And it seems like there's just a little bit of confusion on what the conjecture itself is saying. And so let's take a look at that. It says that every even number greater than 2 can be expressed as the sum of two primes. And so there are some key points in here that we need to be aware of. And the first one is that it says greater than 2. And so greater than 2 means 2 is not actually included in this. 2 is kind of a special prime number. It happens to be the only even prime, and it's kind of weird as an even and weird as a prime number because of that. And so we're not including that number 2 as part of this conjecture here. Then the other key here is this word can. It says that every even number greater than 2 can be expressed as a sum of two primes. That doesn't mean it will always be expressed that way, or it's the only way it can be expressed, just that we can express it as the sum of two primes. And so let's look at some examples. I have an even number greater than 2, 8. And I can write that as the sum of two primes, 5 and 3. So 5 plus 3 gives me 8. And that doesn't mean I can't write it some other way. I could say 6 plus 2 also gives me 8, but that's not what the conjecture is saying. And just because I can write it this way doesn't mean the conjecture is false, because the conjecture is just saying I can write it as the sum, which I can. I can write it as the sum of these two primes, 5 plus 3. And so just because there are these other ways, right, I can write 8 as 4 plus 4 as well, and none of these are prime numbers, and that's okay, because I still can write 8 as the sum of these primes. And so your job as far as this goes is just to look at these even numbers, any even numbers. You need 10 of them, it says, to try out, and see if you can write them as the sum of two prime numbers. And if you can, then it fits in with the conjecture. And just remember, we're not going to prove anything using this kind of inductive reasoning, but maybe we can come up with a good assumption that whether this conjecture is true or not. Okay, hopefully that'll help you with this. Please do let me know if you have any more questions.